Real quick, one more time. A relation is set of word pairs. Okay, we got a new definition. A function is a relation so it's a relation with a condition that must be fulfilled. The condition is each x coordinate. Sometimes we call that the in function relation. It says that each x coordinate corresponds to only one y coordinate. Are A and B both relations? Yeah. Oh, it's not supposed to be a hard question.
Yeah.
They are. Why?
Because they're set of word pairs.
They're both just sets of word pairs. Is A a function? Is B a function? Are they both functions or neither of them functions? Why don't you just... Is C a function?
No.
No, why not?
Because 2 has 2 y steps.
Because the x coordinate of 2 corresponds to 5 and corresponds to 8. Okay. Here in A, 1 corresponds to 3, 5 corresponds to 3. We don't care as long as the same x value only corresponds to one y value. So when we're looking at the list, if it's in roster notation like this, all you do is check. As long as it doesn't repeat an x value, it's a function, guaranteed. If it repeats an x value, not a function. Okay. This is the same as relation A, just the graph of the set. C 2, 5, 2, 8, and 6, 3. This would be the relation C. There's 3 word pairs in. And I think you guys learned last year a test to see whether a relation is a function. Called the vertical line test. How many remember that from last year? Okay. If every vertical line only touches it once, it is a function. Or if any vertical line touches the relation twice, it's not a function. Okay, so 2 ways to say the vertical line test. Let's write that down. If any vertical line touches the relation twice, is this a relation?
Yes.
Yeah. Set of order pairs, some linear relation. Is this also a function?
Yes.
Yes, and how do we know?
Because every x coordinate has only one y coordinate.
Either by the definition, every x coordinate has only one y coordinate, or corresponds to only one y coordinate, or passes the vertical line test. Every single vertical line touches it most once. Okay. We're going to learn in a couple months about circles. Is this a relation?
Yes.
Is it a set of word pairs?
Yeah.
Yeah. Anything on a coordinate plane in black here is just a set of word pairs. It is a relation. Is it a function?
No.
No. At least one vertical line touches it twice, not a function. We can still do lots of math with relations. We'll learn about that later. but just distinguishing what is a function, what is not a function. Okay, another definition. The domain of a relation or function is the range. Is the set of all y coordinates. Sometimes say set of all the inputs, a range is set of all outputs. So what's the domain of A?
1, 4, 5.
1, 4, 5. Close. It's the set containing 1, 4, 5. They say set of numbers. And the range?
The set of 3, 6, 3, 6.
Set of 3 and 6. We got some linear function. What is the domain of this? And how can we figure that out?
All real numbers.
It is all real numbers. Why is that?
Because it goes to negative 2 all the time.
Yeah, this is going down and to the left. So anywhere on the x-coordinate or x-axis, if you go down, you'll eventually have a y-coordinate. Okay. And let's say this is y equals, I don't know, x plus 5. I'm just making up. Could be something like that. Okay. You can plug in any real number for x and always get a y-coordinate. So the domain is all real numbers. We can either write it like this. Or in interval notation, it would be negative infinity, positive infinity. Okay. And what about the range? This goes forever to the right, but it's also going forever up. And it's going forever to the left and down. So it takes on all y values down and all y values up. So the range is all. What's the domain of this?
All real numbers.
Look left and right. It goes forever to the right, forever to the left. Every x coordinate has a y coordinate. All real numbers. And what is the range?
Yeah, so it's a set of 4.
It only has one number in the range. The set containing 4. We're going to learn something later called quadratic functions. This is the example of a quadratic function. What is the domain of this? All real numbers. It goes forever, even it's going up very fast, it goes forever to the right. There's always a y coordinate. The equation for this is y equals x squared. You can plug in any x value, you always get a y value. However, what is the range?
All real numbers greater than or equal to 0.
All real numbers greater than or equal to 0. That's true. It never has any negative values, but it's definitely the set of. And how do we write that down? 0 to infinity. Do I include 0? Yeah, it's on the origin. And do we include infinity? Never. Okay. This has a smallest y value. The smallest y value is this coordinate right here. Okay, and the range has a minimum. The minimum is 0. Okay, if the function was like this, there'd be a maximum. It would take on all of these y values to wherever that point is. Okay, so relations, domain, range, vertical line test, some examples. All right, new topic. What is the absolute value of the number 5?
5.
5. What is the absolute value of the number -5? 5. What is the absolute value of x?
X.
Is it x?
Well, if X is negative,
Well, what if x is -5?
then no.
Is that true?
No.
No. So it's not x. Uh-oh. What is the absolute value of x? What's that? So is it both? Let's try that with this number. Is the absolute value of 5 plus or minus 5? No, it's just the plus. I like the idea, though. Any other ideas? Does it depend?
Yeah.
Yes, it depends on the value of x. If x is positive, it's x. What if x is negative?
It's -6.
It is negative x. Okay. The absolute value of x is we call a piecewise defined function. How did they define it in elementary school?
Like, oh, how many like spaces it is from the origin?
Yeah, like the distance to the origin. That's not really a mathematical expression. You can't just say it's the distance to the origin. We need something better. Okay. So because it depends, we have to break it up into its two cases. So the way we do that is with it's called a piecewise defined function. Did you guys learn this last year?
Yeah, we did. Yeah,
So the absolute value of x is x if what's true about x?
if X is positive.
If x is positive or 0. Okay. So you can write it like this: if x is greater than or equal to 0. And then if x is less than 0, what is the absolute value?
Negative X.
It is negative x. It's the opposite of the value of x. This is called the piecewise definition of the absolute value of x. Okay. And sometimes we write like this. It's x if x is contained in 0 to infinity, or it's negative x if x is in the set negative infinity to 0. The symbol I wrote there is this. Anybody know what that is? It's the Greek letter, lowercase Greek letter epsilon. Okay. It simply means in math, when we're writing down symbols, it means is contained in. So if X is contained in the set, we use a lot in set notation. Okay. And again, when we see one curly bracket, this doesn't mean a set. This is how we write a piecewise defined function. You list all the different pieces, all the different intervals. And you can either write interval notation or you can write inequalities like I did up here, and so on. What's this thing I've written up here?
The absolute value of X is equal to 7.
Is it an expression or an equation?
Equation.
Equation. We call this an absolute value equation because it contains an absolute value. Is it true, false, or open?
Open.
Open. Are the solutions numbers or are they ordered pairs?
Numbers.
Numbers, because?
There's one variable.
Only one variable. Okay. We're going to solve this. What's it mean to solve?
To find the solution
Find the
set.
solution set. So, if X is less than or equal to, less than 0, what does the absolute value of X equal? Hold on.
So that
Since X is less than 0, are we here or are we here? If X is less than 0, we're here.
Yeah.
Okay. So the absolute value of X is equal to this guy. So I replace this with negative X. And now I no longer have an absolute value equation. I just got a simple equation. And we multiply by -1, and we get X equals -7. One of our solutions is going to be -7. And then case 2, if X is greater than or equal to 0, what does the absolute value of X equal to? 7. No. The absolute value of X equals X. Okay. Because we're here, this symbol means this. Okay. And then, of course, the solution here is 7. So the solutions to the absolute value are both of these. We put them both into a solution set. Okay. Sometimes we write this as plus or minus 7. These mean the same thing. It really means both positive 7 and negative 7. Okay, we solved the first. Okay. Before we get to the definition, what do we got to do first?
add one. So yeah, get the absolute value of X.
Gotta get the absolute value all by itself. Right, add 4, we got 10. Divide by 2. 5. Okay. And then we split it up into 2 cases. Greater or equal to 0, absolute value of X is X, solutions 5. once we get to here, is it always going to be plus or minus that number? It is. Okay. So if anytime you have if absolute value of x equals some number a, and a is greater than or equal to 0, then x will equal plus or minus a. X will equal, yeah, let's just do that, plus or minus a. Okay, and then we get, which is two equations, x equals a and x equals negative a. We get plus or minus a. Now we got something inside the equation. Sorry, inside the absolute value. What are we going to do with this?
Just make the solution.
Okay. Think of this as my x now.
Just set it equals negatives.
Okay.
Or -7.
Once we get the absolute value all by itself, just write x minus 5 equals 7, or x minus 5 equals -7. Same thing as x minus 5 equals plus or minus 7, which is two separate equations. Once we get to two separate equations, we're going to solve them separately. We got two solutions. We typically write them in numerical order, but it really doesn't matter. The order of a set does not matter. Ooh, let me change this. First step, -3. And once we get the absolute value by itself, we have to write two separate equations. 5x minus 10 equals 1, or 5x minus 10 is -1. Now we've got two simple linear equations. Add 10 plus 10. Five. We got two solutions. Okay, so for all these, once you get the absolute value by itself, just write two separate equations. They'll either equal positive that number or negative that number. Sound good?
Yeah.
Okay. I think you'll be able to do the homework. So we're going to stop here.